Welcome to VSkap Science. I'm David, and today I'm going to be talking about mass, weight, gravity, and a whole lot else. Now, the first question I have is, I have a piece of paper and I have a phone. I did that backwards, but who cares? I have a phone and I have a piece of paper. Which do you guys think is heavier? Which do you think has more mass? Well, to start off, mass is how much stuff is in an object. And a good way to figure out what is more massive than something else is by feeling their weight. So weight is how heavy something feels, technically how hard something is being pulled towards the earth. So this phone is a lot heavier, it's got a bit more mass than this piece of paper, which really does not have much mass at all. Now, if I drop both of these, which do you think would hit the ground first? Just as is. Well, let's see, there's only one way to find out. And it did take the paper a significantly longer time. Now, the paper is affected by air resistance a lot, so it is going to be pushed around and it won't fall straight down. Now, let me get those and change one thing. So, nothing's going to happen to the phone. It's not really affected by air resistance too much, but I'm going to crumble up this piece of paper. Now, its mass has not changed, its weight has not changed, it still feels as light as paper, but it will not be affected by air resistance quite as much. Now, do you think the paper will still fall slower than the phone, or is one going to fall faster? Well, let's see. 3, 2, 1. Now, you guys couldn't actually see them hit the ground, but I'll just tell you, the phone and the paper hit the ground at nearly the same time, and you could probably see them fall on the screen at just about the same time. Why is that? Well, there is something called gravity. You guys all know what that is, keeps us on the ground, but gravity depends on a couple of different things, and for that, we're going to have to go to the board. So, I've written a bunch of things on this whiteboard, and it looks intimidating, but we can break it down and it'll make a lot of sense. Let's start right here. This is our force of gravity equation. Now, as I said, it is the force of gravity equation, and actually, the units it gives are the metric unit, a newton. So, I will get a certain amount of newtons as my weight, and if you try to convert that into imperial, you'll actually get pounds. So something interesting, when people say, oh yeah, I'm so many pounds, that is force, but when people say, oh yeah, I'm so many kilograms, that is talking about their mass. Now, because we're on Earth, there's an easy conversion between them, but technically in space, you could really only say you're so many kilograms. There's only so much stuff in you. There's no force pulling you in any direction. So in space, we'd all be super skinny. Now, this force is equal to two masses that we're comparing, so you could compare anything you're trying to find the weight of and the Earth, the biggest thing that's pulling it towards itself. So my mass might be put here in kilograms, the Earth's mass could be put here in kilograms, and then the distance between their center of masses. Now, I'm nowhere near the size of the Earth, so for all intents and purposes, this is just going to be the radius of the Earth. But it's squared, and that's important to take note of. So we have my mass, the Earth's mass, and the Earth's radius squared times g. Now g is just some constant. I wrote it out up here. It's a huge number. You'll end up being able to look it up if you ever have to use it. But it is just a conversion factor. It converts everything into nice newtons that are easy to work with. And it's also really, really tiny, so as it turns out, gravity is not a very strong force, but the Earth has so much mass that it ends up being fairly powerful. Now, this allows us to find the force of gravity, but any force can be written as F equals ma. Now, this m is whatever we're measuring. If I am accelerating towards the Earth, then we will use my mass and my acceleration. Now, since that's a force, and that's a force, and those are the only forces we care about, we can actually take this and substitute it for our Fg. So now we have m1a equals g, that same constant, m1, take note, those are the same two m's. m2 and r squared. Now, as I said, r squared, it won't really change, at least on Earth. Now, we have an m1 there, we have an m1 there. Those are the same masses. So, I will always weigh the same, or I should say I always will have the same mass. So actually, we can cancel these two masses if you divide both sides of the equation by my mass. That just leaves us with A, my acceleration due to gravity, equals the constant times the mass of the Earth divided by the square of the radius of the Earth. And actually, we know that number, we can figure out this number, we can figure out that number. And if we crunch all those numbers, we end up getting the acceleration due to gravity for me or any object on Earth about equals 9.81 meters per second squared, which is the unit of acceleration. Now, as I said, there's no m1 here. So I could take this and it'll fall just as fast as I could. I could take this marker, I could take this phone, I could take a piece of paper, I could take anything, and they would all fall towards the Earth at 9.81 meters per second squared. Unless you count air resistance, but that goes back to the paper that we saw earlier. So now you can see the mass of an object or its weight, how heavy it feels, how much stuff is in it, does not affect how quickly it'll drop. The only thing that matters is the fact that we are here on Earth and that we are a certain distance away from the Earth. How big something is, it's pretty much negligible compared to the weight of the entire Earth pushing down on it. So, that was a bit of an introduction. If you guys want to see more about this or any other science topic, let me know in the comments. And, this is my first video. I'm not going to sugarcoat it. I'm not sure how this is going to do, and there's a blizzard going on outside. I excuse for any audio issues. I hope you can too. And if you liked it, you can leave a like. If you want to subscribe, please, I would very, very much appreciate it. I'm going to hope to put out more videos coming shortly. If you want any specific physics topic covered, or even other science, I don't know, maybe I'll be able to do more. But let me know in the comments, or you can message me somehow, and I'll see you guys next time. Just thinking about this now. This was a pretty massive video for me.